Brilliant. Thanks ever so much for inviting me here, and it's great to see so many people out here. Here to talk about Mint Innovation, cyanide-free gold recovery. We're a clean tech company. We use biotechnology to apply biotechnology to a complex clean technology. And before I crack into it, I thought I'd give you a bit of a background of how we started, how we kind of ended up in this space. So previous to founding Mint, I was with LanzaTech for about 7-8 years. Some of you know LanzaTech as a clean tech company, one of New Zealand's most successful clean tech companies, taking steel mill waste gas and converting it through to biofuels and biochemicals using a microorganism. Now, I led commercialization activities at LanzaTech for about 7 years. And as most of you know, around about 4 years ago, they up and left the country and moved all their operations to Chicago. I chose to stay here and look for a new opportunity to kind of apply some of the learnings and create some more value in New Zealand. What were those learnings? Well, there's a couple of the challenges of clean tech is the cost of production of a biofuel or a biochemical. And one of the biggest problems you've got there is that the cost of a feedstock. You think about bioethanol, for example. You've got the cost of the feedstock, a sugary plant or a cellulosic plant, and you've got the value of the product. There's typically a very, very small differential between the cost of the input and the product you're producing. In some cases, it's actually the wrong way, and you rely on incentives. And what these plants are typically doing, they're relying on plants that cost upwards of $100 million to try and make a profit from a very, very small differential. So we started looking at opportunities where, number one, we're looking for very, very low capex, low opex processes. But number two, we're really trying to find microbial processes that really target very, very high value products. And in the first instance, we're looking at gold. I'll share with you some silly numbers. $142 billion, that's how much gold is dug out of the ground every year. 20% of that goes into electronics. So about $28 billion worth of gold goes into electronics. And of course, the life cycle of electronics these days is between 3 and 5 years. So your cell phones, your laptops, the small IT equipment typically lasts 3 to 5 years. And from there, it's largely discarded into landfill. Tremendous amount of value obviously going into landfill. Some of that value is captured. The primary way of capturing that value is through a copper smelter. There's a handful of copper smelters around the world that have been retrofitted with a gold processing capability. So they use cyanide to extract gold and other metals from the slag material that floats off the copper smelt. To be profitable, to be economically viable, these facilities, they require continental volumes of electronic waste, of printed circuit boards. So they're literally sucking up all the electronic waste from countries all over the world to try and get vast volumes so they can chuck it in the smelter and make a small profit out of it. There's no secret that there's also illicit trade, and quite a lot of the electronic waste is diverted to developing countries where it's dealt with inappropriately. And you've all seen the videos, the news footage creates environmental and humanitarian catastrophes. So what we've done, we've developed a unique, entirely scalable solution. What we're looking to do is build plants in the city of discard. So where your electronic waste is being discarded, we can scale our plants so that they can collect that value, capture that value at the point of discard. So at the point where the aggregators, the recyclers are already collecting. So I apologise for using slides. I've been on the road for a couple of months, and Hong Kong is obviously not particularly relevant to New Zealand, but gives a good example. So Hong Kong is a city of about 5 million people, and the amount of waste that generates, we're able to build a plant of about $5 million plant, and the gold that can be recovered from that waste is about $40 million. Hong Kong, about 5 million people, obviously very similar size to New Zealand, so a similar opportunity here. Cities like Melbourne, 4 million people, Sydney, 4 million people, and obviously significant cities around the world, similar amounts of value that can be made, generated. The Shenzhen region in Hong Kong, obviously a much bigger opportunity. The scalable nature of the plant means that we can address an electronics hub, and for a small capex footprint, there's vast revenues generated. What does our proprietary technology look like? Well, we work with the recyclers. So there's recyclers currently collecting electronic waste. They're breaking it down into different streams. They've got plastic streams, they've got metal streams, they've got printed circuit board streams. As the printed circuit boards that contain all the value, they contain all the gold, all the palladium, and all the copper. So they're collecting it at the moment. They're shipping it off either legally or illegally, exporting it around the world, and being paid cents on the dollar for the value that's captured. Instead, we're working with these guys locally to capture that value locally. We build a mint plant. We take their waste, we grind it up into smaller fragments. Then we dissolve all the metals off into a single leach. So there's a liquid that contains all the metals from that electronic waste. And then we apply our magic microbes. Our microbes go in there, and what they do, they act as a sponge, but they're a very, very specific sponge. They very, very specifically go in there and target gold and palladium. And what they do, they just literally suck up all the gold and palladium. And then because they've got mass, you can separate them out again. The critical piece of IP here is that these solutions, they're very, very low concentration of gold, but very, very high concentration in a range of other less valuable metals. And what our microorganisms go in, they take very, very low concentrations of gold, let's say 10 parts per million, 10 grams in a ton. And what they do is they concentrate it, they suck it up, concentrate it up, and when you've got these dry bugs out the other end, they're between 5 and 10% gold. So they're literally coated with gold. And that's a 5 orders of magnitude increase in concentration. And then you just set fire to the bugs, and that leaves a gold-rich ash at the end that is easily refinable. The key advantage of this low capex, obviously the very, very cheap processing was a key tenet of the foundation of the company. Low operating costs, again, enables us to return more value to recyclers. Small footprint. These plants look and feel a little bit like a microbrewery. So very, very small vessels for processing significant volumes of waste very, very quickly. Dominant IP. We filed 4 patent families already. I was, as I said, at LanzaTech, I was a patent attorney originally, and then kind of developed into all things commercial. So applying the same principles that we applied at LanzaTech. Not spending all of our time filing patents, because I don't think we need 30, 40 patent families, but really focusing on those core patents to protect the space. The distributed nature of this means that we can look to distributing this, building these plants everywhere that waste is collected, and it's compatible with existing infrastructure. So these recyclers are already getting the waste, they're already recovering the value, they're just not getting a great deal of that value themselves. What have we been doing? Where are we at? Well, we've been processing the waste in our Parnell laboratory for well over a year now. We've optimized the process, optimized the chemistry, optimized the biology, and now we're at a stage to take it from a pilot plant where we've been processing 10 to 20 kgs at a time, take it to the next stage, which is a pre-commercial demonstration of the technology here in New Zealand. We've designed that plant. We're currently going through a feasibility for that study for that plant, confirm the economics of it. Now, typically demonstration plants they're typically like pouring money into the ground. In this case, because of the nature of the product, this demonstration facility is borderline profitable. So we're actually building a commercial unit with the funds that we're raising. We're looking to close an investment round later this year, build this demonstration facility, and have that demonstration facility, a pre-commercial demonstration facility at full capacity by the end of next year. From there, it's a simple step, literally a 5x scale up from there. So all the scale up risk is gone to start deploying these things commercially. And with the following wind, we'll be looking to deploy that first commercial plant in the beginning of 2020. The low capex nature of these plants mean that we've got the opportunity to build, own, and operate the plants that we deploy around the world. As we prove out the technology through that demonstration facility, we kind of tick off all the key technical and commercial milestones. We can then finance these plants throughout the world. and look to deploying them in cities where the greatest needs arise. That rapid deployment is driven by a number of things. Firstly, profit incentives for the recyclers, but probably the most interesting thing from our perspective, most countries around the world have legislation that restricts the export of the material. It's currently being exported to developing nations, so restricts that export if there's a local solution. So we'll provide that local solution, and the addressable market is significant, as is the potential returns for us. This is we're conservatively saying if we deploy a plant, 5,000 tonne per annum plant, one per year, then the revenues are they get silly very quickly. We're raising, again, sorry, this is in US dollars, but we're raising $4 million. We're raising about between 4 and 5 million New Zealand dollars at a pre-money of 13 to 15. And we've actually got committed about 2 million US, so 2.5 million New Zealand already. And the use of those funds, deployment and global growth. Thank you for listening. Look forward to any questions.